Good day to you all there. We are still on factorial permutation and combination, but this class today will be focusing on combination. Combination can also be regarded to as selection, as permutation is always being referred to as the arrangement of a value or arrangement of an object. Combination is selection of an object. Now, the formula for combination goes thus. We have n combination r will be equal to n factorial all over n minus r, open the bracket, factorial r factorial. Compared to the permutation where we have n permutation r is equal to n factorial over n minus r factorial. You can see the difference between them. Now, the relationship that can happen between combination and permutation is like this. N combination r can now be equal to n permutation r over r factorial. How do we mean this? This is what I mean here. Now look at n permutation r. Where we have, let's say, n combination r is equal to what? N permutation r. What is the value of n permutation r? That's n factorial all over n minus r factorial divided. You can see that this is divided by r factorial, which is going to change you n factorial over n minus r factorial times 1 over r. Like this, we are talking about n combination r is going to be equal to n factorial all over n minus r in bracket factorial r factorial. You can see when you multiply this r at the denominator here by this value here. That is the relationship between combination and permutation. You can see that n combination r is this formula, where n permutation r give us this formula. Then the relationship between combination and permutation is the permutation divided by r factorial. Now, if you have a question of this nature that says we should find the value of 9 combination 6, that is shown here, 9 combination 6 will be given to be, according to this formula now, our n is 9. That will be 9 factorial over 9 minus 6 factorial, 6 factorial. That is the translation. We can see that r is our 6 here. So which is going to be equal to 9 factorial over 9 minus 6, that's 3 factorial, multiplied by 6 factorial. Now, if I want to simplify it further, I will now say 9 factorial all over 3 factorial multiplied by 6 factorial, and which is going to be equal to 9 times 8 times 7 times 6 factorial. Because I have 6 factorial at the denominator here, all over 3 factorial multiplied by 6 factorial. This 6 factorial, we call this 6 factorial. Then we are having 3 factorial at the denominator, which is going to be equal to 9 times 8 multiplied by 7 all over, what is 3 factorial? That's 3 times 2 times 1, which is equal to 9 times 8 times 7 all over 3 times 2. When you cut this one, don't let me put this one yet. If I cut this one, 3 here 1, 3 here 3, 2 here 1, 2 here 4. I'm going to have 3 times 4. We have all the value of the denominator has become 1 now. Now, 3 multiplied by 4, that is 12. And 12 times 7 will give us 84. That is 84. That is the answer to the question, which is 9 combination 6. Another question also comes there that also asks us to find the value of 7 combination 3. As we did this here, our n is 7, where our r is 3. That will be 7 factorial over 7 minus 3 factorial 3 factorial, which is equal to what? 7 factorial is 7 times 6 times 5 times 4 factorial. Because I know that I'm going to get 4 factorial at the denominator, 7 minus 3 will give us 4 factorial 3 factorial. When I call this off, I'm having 7 multiplied by 6 times 5 all over 3 factorial is 3 times 2 times 1, which is equal to 3 times 2 times 1. You can see that 3 times 2 times 1 can cut this one here, which this one can cut this one can as well cut it. So we're having 7 times 5, which is equal to 35. That is the answer to that particular question again. That is how you solve some of this kind of question that has to do with combination. And look at the relationship we have. We relate that combination and permutation together. Stay tuned. We have some other questions that are still coming your way. We have a twin question here. There's one here, another question here. The first one says that we should prove that 7 combination 3 is equal to 7 factorial all over, as we have the question here, all over 3 factorial 4 factorial. Now, according to the formula of combination, this is our n and this is our r. We have it to be 7 combination 3 is going to be equal to 7 factorial all over 7 minus 3 factorial 3 factorial, which is because n combination r, as we know, n combination r is equal to n factorial all over n minus r factorial r factorial. Now, this case now, this one is going to become 7 combination 3 is equal to 7 factorial over 7 minus 3, that's 4 factorial 3 factorial. You can see that it is similar to the question given to us. So in that case, we have been able to prove that this expression here is equal to this value here. Now, for the next question says that we should show that 7 combination 3 plus 7 combination 2 is equal to 8 combination 3, as we have it here. Now, what we need to do here is to solve out the value of this 7 combination 3 plus 7 combination 2. Let's try to solve that. Then we'll also look for the value of this 8 combination 3. 7 combination 3 now. 7, that will be 7 factorial all over 7 minus 3 factorial 3 factorial plus 7 factorial all over 7 minus 2 factorial 2 factorial. That is the value of this. And 8 factorial is what? 8 combination 3, rather, excuse me, 8 factorial over 8 minus 3 factorial 3 factorial. So now this one, 7 factorial, will become 7 factorial all over 7 minus 3 is 4 factorial 3 factorial plus this one is 7 factorial all over 7 minus 2, that is what? 5 factorial 2 factorial, which is equal to what? 8 factorial over 5 factorial 3 factorial. I hope you are communicating with me. Now, this place we are going to have 7 times 5 times 7 times 6 times 5 times 4 factorial all over 4 factorial 3 factorial. That is the value of this particular first term here, plus 7 times 6 times 5 factorial all over 5 factorial 2 factorial. Why do I stop here? It's because I have a value at the denominator that is equivalent to that at that particular value where I stop. So that's why I stop there, so that they can be able to cut one another. Is equal to 8 times 7 times 6 times 5 factorial all over 5 factorial 3 factorial. This 5 factorial, call this 5 factorial here. So I'm going to have this one cut each other here. 4 cut A, and this 5 factorial call this 5 factorial A. Now, if you look at this, 3 factorial will be equal to 3 times 2 times 1. That will be 6. So it cut this one. So we are having here 7 times 5 is 35. Plus, we are having 35 here. Plus, this here, now we have this 5 has been cut off. This 2 factorial. This what we have here? 2 divided by 6, that will be 3. 2 times 1 is 2 factorial. So 2 times 2 in 6, that will be 3. 7 times 3, that will be 21. Then we are having here, this is 3 factorial. 3 factorial is as well equal to 3 times 2 times 1. That is 6. It cuts this. So we are having 35 plus 21. That will give us 56 is equal to 8 times 7 is 56. So it has been proven that 7 combination 3 plus 7 combination 2 is equal to 8 combination 3. That is very, very clear, proven. Stay tuned for the next question. This question here says, in how many ways can I choose 2 red ball and 3 black ball from a bag containing 5 red and 6 black ball? So the bag contains 5 red, 6 black. Then we want to choose in the bag to choose 2 red and 3 black. Am I right? Yes. 2 red and 3 black balls. Now, this is our selection. We want to select it from the bag. That is going to be equal to 5 combination. What is the red here? 2 multiplied by 6 combination 3. In this case here now, can I go ahead and say find the value of this expression here? 5 combination 2, that will be 5 factorial all over 5 minus 2 factorial 2 factorial multiplied by 6 factorial all over 6 minus 3 factorial 3 factorial. So we are having it to become 5 factorial all over 3 factorial 2 factorial multiplied by 6 factorial all over 3 factorial 3 factorial. So we were having 5 times 4 times 3 factorial all over 3 factorial 2 factorial multiplied by 6 times 5 times 4 times 3 factorial over 3 factorial multiplied by 3 factorial. This is multiplication as well. Now this place here, this one we call this one off. We are having 5 times 4. And this 2 factorial is as well equal to 2. 2 times 1 is 2 factorial. 2 divided by 4, we are going to have 2 here. So we are having here 10 value that remain. 10 is the value that remain. 5 times 2 is 10. And here now, this 3 factorial will goes with this. Now, this is 3 factorial. 3 factorial is as well equal to 3 times 2 times 1, which is equal to 6. 6 divided by 6 here, we leaving behind 5 times 4, which is going to be equal to or multiply by 20. So 10 times 20 will give us 200. So the answer to the question that is given to us here, that in how many ways can 2 red ball and 3 black ball be chosen from a bag containing 5 red and 6 black ball, is 200. 200. Stay tuned for the next question. Next question we have here that says, in how many ways can a team of 11 players be selected from 13 boys? This is very straightforward question. Once it is selection, you should know that we are going to apply the combination formula. So we are having how many players to be selected? To be selected 11 players, available players from 13 boys. So we're going to have 13 combination 11, which is going to be equal to 13 factorial all over 13 minus 11 factorial 11 factorial. Don't forget the formula for combination, which is going to be equal to 13 factorial all over 2 factorial. You know that's 13 minus 11 will give us 2, then multiply by 11 factorial. It's going to eventually give us 13 multiplied by 12 times 11 factorial all over 2 factorial multiplied by 11 factorial. We can cut this 11 factorial from one another here. So 2 here, 2 factorial will give us 2. 2 in 12, that is 6. 13 multiplied by 6, the answer will be equal to 78. So the question that is given to us that in how many ways? We have 17 ways by which 11 players can be selected from 13 boys. Do stay tuned as we have the next question. In how many ways can 3 men and 2 women be chosen from 6 men and 4 women? We have 6 men, 4 women. That is the available number of men and women that we have. This one are the available, and the chosen to be chosen to be chosen will be, we are having 3 men and 2 women. So we are going to just apply this rule of combination. Once they are to be selected from this, these 2 and 3 are to be selected from this available men and women, we are going to have it to be a combination expression that will be equal to 6 combination 3 multiplied by 4 combination 2, which is going to give us 6 factorial all over 6 minus 3 factorial 3 factorial multiplied by 4 factorial all over 4 minus 2 factorial 2 factorial, which is going to give us 6 times 5 times 4 times 3 factorial all over 3 factorial. 6 minus 3 is 3 multiplied by 3 factorial. Multiply by that multiplication sign. 4 times 3 times 2 factorial all over 4 minus 2. That's 2 factorial. Then 2 here, 2 multiplied by 2 factorial as well. So which is going to give us this 3 factorial. We call this 3 factorial here. Then 3 factorial is as well equal to 3 times 2 times 1, which is going to be equal to 6. 6 divided by 6, this one will cut each other. So leaving behind 5 and 4. 5 multiplied by 4 will give us 20. 20 multiplication sign. So here, 2 factorial here, call this 2 factorial here. We are having 2 factorial at the denominator here, left. So 2 factorial means 2 times 1, that's 2. 2 in 4, 2 here 1, 2 here 2. So 2 times 3 here will give us 6. So we are going to have 20 multiplied by 6 will give us 120 ways. 120 ways by which we can choose 3 men and 2 women from 6 men and 4 women. 120 ways. We implore you to subscribe to our channel for you to be able to have access to all our soft question on all topics on mathematics. We also have some other subject that are well prepared for your enjoyment and for your simplification and understanding of most of the subjects that can be a little bit difficult for you at school. Thanks and God bless.